A nerve impulse begins with a graded potential, and a graded potential is just a very localized change in the membrane potential. The changes in the potential are very, very small, and they don't spread far from where the stimulus occurs. These are caused by a stimulus that will open the gated ion channels. For example, chemically gated sodium ion channels. At resting membrane potential, the chemically gated sodium ion channels are closed. The membrane is exposed to a chemical that opens the chemically gated sodium ion channels, and sodium rushes into the cell. When those positive charges enter the cell, it's going to reduce the membrane potential. That is, it's going to make it less negative. For example, negative 70 to negative 65 millivolts. When the membrane potential becomes less negative, it's called depolarization. When these sodium ions enter the cell, they spread along the inside of that membrane. Now, the inside of that membrane is negatively charged, and these positive sodium ions are attracted, and they spread along the surface of that membrane. The extracellular sodium ions move along the outer membrane toward the channels, because these sodium ions have entered the cell, and more sodium ions are coming toward the channels to replace them. This is called a local current. The amount of depolarization decreases with distance from the stimulus. The ions enter at that one location, but then they're going to spread in all directions. A change in the membrane potential is definitely proportional to the stimulus. A larger stimulus will open more channels, and you'll have more sodium rushing into the cell and a greater depolarization. So we'll look at what happens to the membrane potential with each of these, with the chemically gated channels and potassium gated channels. So here we have a chemical stimulus opens the sodium ion channels, and the membrane is depolarized slightly. It becomes less negative. Here it looks like about negative 65, and this is because the sodium ions enter the cell. When that stimulus ends, the membrane is going to return to normal, because those excess sodium ions in the cell are transported back out of the cell. So this return to normal to the membrane potential of negative 70 millivolts is called repolarization. On the other hand, if you have a potassium gated channel, this is going to cause the chemical stimulus opens the potassium ion channels, and potassium enters the cell, making the cell more negative, making the membrane potential more negative, or hyperpolarization. When the stimulus is removed, again, there is a return to normal. So here are the most important things to remember about graded potentials. The membrane potential is most affected at the site of stimulation, and the effect decreases with distance. The effect spreads passively through local currents, and those currents are caused by movement of ions. The graded change in the membrane potential may involve either depolarization or hyperpolarization. It depends on which ion is involved. For example, opening the sodium ion channels will cause depolarization. Opening the potassium ion channels will cause hyperpolarization. And the stronger the stimulus, the greater the change in the membrane potential, and the larger the area affected.